Was the 500th episode of Run As Radio. And one of the things I mentioned on the show was in April 2007, we did our first episode. PowerShell was still called Monad. It was brand new. And it was this, is this going to be important or not? It's like show number 6 of Run As Radio. We talked about how PowerShell is going to take over the universe. And roughly 10 years later, clearly you have succeeded. And so, ladies and gentlemen, put your hands together for my friend and now technical fellow, Jeffrey Snover, the father of PowerShell.
Howdy. So today I'm going to talk to you about Windows Server 2016. And we believe that it's just an awesome application platform. And I'll tell you why. So again, I'm Jeffrey Snover, technical fellow. I'm the chief architect for the Enterprise Cloud Group. That's the group that brought you Windows Server, Operations Management Suite, System Center, and Azure Stack. So first I thought I'd start by providing some context. Often I find that you see a lot of things going on in the industry, and it's kind of hard to get in focus. Like, how do I think about this versus how do I think about that? So I've found that this way of thinking about server helps me analyze the various things that are going on, the various things that I see. So really, if you think about the evolution of the server, it all started back with Windows NT. Right? With Windows NT, Microsoft took Dave Cutler's awesome kernel, we ran it on PC class hardware, and we put a GUI interface on it. And we transformed the world. Prior to this, servers were really the domain of the princes and high priests of technology. But after NT, everyone could buy, deploy, and run their own server. So it was server for the masses. And we transformed the world with this release. Now this was so successful and the PC client was so successful, it brought about the next era of Windows Server. And that was the era of the enterprise servers. In Windows 2000, we added Active Directory and group policy. And the first time now you could go and manage these things as a coherent whole. You had single sign-on, so you could use all the resources of your enterprise in a coherent fashion. With 2003, we introduced .NET. And with .NET, it brought about the line of business application explosion, where we democratized that. Prior to this, line of business applications were done by the high priests and princes of technology. And now with .NET, sort of everybody was able to produce their own mission-critical line of business applications. And there was just a gazillion of those. There were so many, in fact, that it brought about the next era of Windows Server. And that was the era of the data centers. Here we had to manage things differently. Prior to this, we managed things with GUIs, local GUIs. The enterprise era, we did RDP and remote GUIs. But when you had data centers and you were going to have a lot of these things and they were going to be running your business, you needed to manage things differently, and that was PowerShell. That's where PowerShell came to play. Now here in the data center era, we had great scale up, we had great scale out, we introduced virtualization, and we started the hard, heavy road of reworking our storage stack. Now these were the technologies, Windows Server 2008 and Windows Server 2012, that Azure was built upon. So the Azure team took these technologies and built Azure on that. And then what we've done now is we've taken the lessons and then sometimes the very code of Azure, and we're bringing it back. Because prior to this, clouds, once again, were the domain of the princes and the high priests of technology. They were really the only people that could really get a cloud working. And now we're bringing about the era of cloud servers with Windows Server 2016. So what I find is that there's different ways to manage things. There are different types of application patterns, etc., for each one of these eras. So keep that thought in mind, and you'll see it pop up again and again. So we started our planning for Windows Server 2016 by talking to customers. And here are the sort of things that we heard them say. We heard them say, hey, hearing too many stories about companies getting hacked and then not knowing about it for months. Actually, if they knew about it months, they'd be very happy. The reality is people aren't hearing about this for years. Years later, they find out that they were hacked, right? People love the public cloud, but how do they get those benefits in their own data centers? People wanted deployment flexibility. They wanted to be able to build an application and then deploy it to a public cloud or to a private cloud? And then how do they manage shadow IT? Right, shadow IT, where the business people work with the developers, collude with the developers to get something out to the public cloud, out and deployed in the public cloud by sidestepping IT. That's called shadow IT. In fact, a couple weeks ago, we were talking to some developers, and they literally used the phrase that they were outmaneuvering the dinosaurs in order to get their application up on the cloud. Of course, this creates a mess, as then IT has to come back and clean it all up with adherence to policies, making sure the privacy information's done, making sure it's secure, etc. So people wanted help with that. And then people have been worried about, hey, are we on the right path? Are we on the right path? We've been doing this virtualization and these data centers, and they don't look anything like what people are doing with the cloud. So are we doing the right thing? Then when we talked to them about the cloud and what they wanted to see there, boy, did we get a strong signal there, right? Hybrid cloud's the strategic direction. We're all in on the hybrid cloud. And my favorite here, hybrid cloud, of course. Is there any other answer? So people are very passionate about this. So the key thing to get in focus here is that the cloud is a model. It is not a place. The cloud's a model, not a place. And what people want to do is they want to be able to write applications to the cloud model and then decide, I'd like to just run them in the public cloud, or I'd like to run them in a service provider, or I'd like to run them in the private cloud. And they want the right to be wrong. They want to be able to develop this application, deploy it somewhere, and if they decide they're wrong, they want to move it to another place without any drama, okay? So Windows Server is the foundation of Microsoft's cloud. Make no doubt about that. There's been some confusion about that in the past. The very early versions, like the veriest early versions of Azure, I'm not even sure we called it Azure back then, was based upon a branch of Windows Server. They went and added a bunch of stuff. Guess what we did? We took those changes, put it into Windows Server, gave it back to them. Now Azure runs 100% on Windows Server, okay? So Windows Server is the basis for on-premises data centers. It is also the basis for Azure. Now what we're doing is we're taking both the lessons and in many cases the very code, we're bringing those back on-premises in both the form of Windows Server and Azure Stack. The cloud really is changing everything, right? And it's raising the bar on the expectation of what's delivered by applications. So everyone knows the cloud gives me hyperscale. If I deploy an application and it's successful, I want to be able to respond to that without any drama. No, oh, good heavens, it's successful. Now I got to go buy a bunch of servers. I got to deploy those servers. I got to provision them and start a multi-month provisioning process. No, if it's successful now. I want to scale up now, and I want to get those orders now, and I want to respond to my customers now, right? So hyperscale. It also latency, right? You can deploy cloud applications very close to your customer so that you have low latency. Availability, the ability to have lots of different instances of something, and when failures occur, does not mean that the application fails, just means an instance of the application fail. And if you think about it, this is just a pattern we've been doing over and over and over again, right? UDP versus TCP, right? UDP has packet failure. If you want to, you can code to that, and sometimes you fail, sometimes you don't. But TCP says, oh, hey, those things can fail, and I've written my protocol in a way that knows that they're going to fail and accommodates it so that my consumer, my user, the user of TCP, doesn't see that, okay? Before that, by the way, we did the same thing with SNA versus TCP. SNA, great protocol from IBM, but it was hardwired. If anything went wrong, you're doomed. TCP knew and was designed knowing that things would always fail and can reroute. That's why you hear about TCP and you don't hear about SNA. And agility. When we first started talking about this cloud, everyone talked about cost. Cost, cost, cost. Oh, it'll be cheaper, cheaper, cheaper. And in some cases it definitely is, and in some cases it's not. But that's not really why people are going to the cloud. They're going for these other reasons, and kind of one of the most important ones is this agility, the ability to get things out there, move quickly, scale up, scale down, move to where you want them to be, take advantage of code that other people have written to make yourself better. So for instance, anybody watch the Olympics this year? Right? The entire Olympics was run on Azure, right? Just incredible scaling, huge increase in computing over the previous Olympics, right? The previous Olympics were what, 10 or 720p, this was all 1080p, a lot more. So imagine your boss said, hey, we want to do some video streaming and we want to transcode to all these different formats. Would you know how to do that? And the answer is, for most of us, would be no. Well, the answer is Azure has a service, and it does that transcoding for you. And all you have to do is to use it, and that's what the Olympics did. Anyway, so the expectations of applications is going up because of the cloud. Often as I talk to executives, they say, I just don't get it. Facebook is able to do applications like this. Google and all these other, Twitter, they can do these things. Why can't my guys do those things? The expectations are growing, right? So you can take your application and you can run it in the cloud. And when you do that, there's lots of patterns, right? You can run a monolithic application, right? Lift and shift, and you will get a certain degree of flexibility when you do that. However, really to get the best flexibility is when you start to break things down and do things as microservices. Lots of different components talking to each other via protocol, each with their own life cycle. We'll talk more about that. But then you run those things in virtual machines or containers. You might want to use a orchestration service like Fabric Service, or use Azure Functions, where you're not really managing and provisioning a server itself and then running your code on it. You're just giving your code to a service, and then it figures out how to host it, and to host it in an always maintained, up-to-date, patched environment. And again, people want to be able to run this both on premises and in the public cloud or in a service provider environment. So let's step back a second and say, well, what's really going on here? Why are there these things like shadow IT? And the reality is that there's this tension going on in the marketplace, right? And that's the tension between the business people and IT. What the business people are seeing, and this is super critical to get in focus, they're looking out there and they're seeing the folks that are doing it right, and they're getting such a compelling business advantage that they just know they have to do that or they're going to die. And so then they go to their IT organization and say, hey, we got to do this. Well, look, for IT guys, we've been spending the last however many years, 10, 20, 30 years, providing stability and predictability, nice, boring environment. And now all of a sudden you want this agility stuff. Those two things, there's a tension there. And often when IT does not give the business what it needs, that's when you get the shadow IT. By the way, here's a great example. Early days of Azure, we had a customer, I'll try and anonymize this, I'll say an auto manufacturer, who had this very situation. The marketing guys wanted to have this big internet campaign, go talk to customers, get their information, all that. And they went to IT and said, how long would it take? And they're like, 3 years or something, very long time. And they said, oh, the heck with that. And they went to an Azure partner, consultants, and these guys were able to leverage Azure, put together this campaign in an incredibly short period of time, and boom, the campaign was a huge success. It was one of the early showcases for Azure and demonstrated the power and agility and the ability to drive your business forward through the cloud. But as I thought about that, I then thought to myself, wait a second, you're collecting all this PII information. Do those consultants know that company's policy around PII? Like, are you backing it up? Are you securing it, all that? And the answer, I don't know what the answer is, but my guess is probably not. And now they've got all this incredible asset, but now the IT department has to go back and clean all that up. Okay, so there's this tension is what I'm saying, but I will tell you this, and this is the most important thing to be aware of, is the business has to be successful. And so they will do whatever it takes to get that business success. And if IT doesn't provide it, they'll do it anyway. And they should. Well, we believe that the way you resolve this tension between the needs of the business and the needs of the IT is through a cloud service delivery model. Now, before we get into that, I want to talk a little bit about microservices, right? Microservices, all the rage. How many people are doing stuff with microservices? Okay, how many people think that they should be doing something with microservices? Right, lots more hands, right? So let's talk about that, because lots of people have different views about what a microservice is. I want to give you my view, right? And this is Jeffrey's view of microservices. But I think if you adopt this view, it will serve you well, right? It'll help get it in focus. And the heart of it, in my mind, is environmental decoupling, okay? So in the past, we'd have an application which is composed of lots of different components, and they would all share the same environment, okay? Often that environment was a process, right? You would write a component and you deliver it to me as a DLL, and I would link against that. Now we're in the same process. So if it turns out you're messing up the memory, you're messing up my memory, right? And so if I'm messing something up, messing up your memory, okay? Or let's say it wasn't through a process, it was through a service. So you provide a service, but I'm running on the same machine. Well, we're on the same machine, right? So anybody ever have a problem with MSVC RT41, right? That was that DLL hell where they somehow had different copies of the same library, but they were incompatible, and so everything's happy. And by the way, this literally happened to me. We had a big trade show. I was going to be the host. I was going to be on stage for an hour, big thing. We're going to do live demos of our management products, right? We spent a bunch of time getting everything perfectly systems integrated, ready to go. The night before it ships out, one of the teams comes in with their floppy disks, adds a new MSVC RT41. And so then I got up on stage and I go to do a test, and nothing worked except that guy's demo. His demo worked. Everything else failed. So this is environmental coupling. Now, microservices is environmentally decoupling. And here's the heart of it. The heart of it is that networking has gotten really, really good. Bandwidth is great, latency is great, getting better on each one. And what that allows us to do is it allows us to do what we used to do, integration through API calls and DLLs, we can now do through protocols. And when you do it through protocols, the different components can be in their own environment, right? They can be in separate machines. And when they're in separate machines, you can go get the version of the DLL that works for you, and I can get the version that works for me, and that's fine. You screw up your memory space, you're not screwing up me. I'm just talking to the protocol. Now, because of that, you can also say, hey, I've decided to go to the next version of the operating system, or the one after that, or to re-implement my code from this language to that language, okay? Additionally, because I'm talking to you through a protocol, if you use the right sort of protocol, you can put a software load balancer in front of that. And all of a sudden, instead of talking to one machine, it looks like you're talking to one machine, but you can be talking to 1, 2, 200, 2,000, back down to 200, you can scale. So it gives you incredible flexibility. Additionally, it says, hey, you run your component however you run your component, release whenever you release, go with God. I'm going to do my thing, and we're just going to make sure that that protocol always works. So it allows teams to scale up and work together very rapidly. And by the way, we're seeing that. We're doing microservices in Azure and OMS, and we're seeing just amazing synergies because of it. So it's a great world. That's the heart of microservices to me. So microservices are awesome. Everybody loves them. But the reality is that most of us in this room are dealing with these monolithic legacy applications. And what I'm here to tell you is that ultimately you need both. And containers can really help. You can take an existing sort of monolithic application and run it in a container to give you a certain level of agility and flexibility and bandwidth to then go back and start refactoring your code. And as you can refactor it, maybe you can put it into 2 containers, and from 2 to 10, et cetera, and grow. So containers you should not view as, to get to microservices, I got to throw everything away, start from scratch, build it all as microservices in their own container. You definitely do not have to. Also, microservices do great with containers, but they're no way tied to containers. You can do microservices any way you want. So this is Microsoft's view of the modern application platform. And we believe that when you adopt this platform, you are going to be happy campers, right? You are going to be able to respond to the needs of your business very agilely and very successfully. At the heart of it, at the base of it, you have both Azure and Azure Stack, right? Now, I want to be clear on this because there's been some confusion. Azure Stack is not every service available in Azure running on your data center. Azure has like content distribution networks. Those aren't going to run on your data center, okay? Not at least in the first version. What we've done, Rasinovich and I talked, we defined a set of APIs and services that most application developers are using in Azure. And those are the first set of services that we're going to make available on premises and service providers. And when we get that out, then we're going to get back together, pick the next scenarios, big data, IoT, whatever it is, and we'll find the services and APIs required to support that. We'll do that next, and then we'll do the next scenario and the next scenario. So in other words, it's going to start off with the core and then grow over time. Now, you will have the same Azure Resource Manager. It's the exact same code running in both. Windows Server is a great environment. You can run Windows Server. This should actually show Windows Server or Linux. Both are first-class citizens in these environments. But on Windows Server, you can run things in virtual machines, containers, and the Azure Service Fabric. In fact, no, actually, Linux you can run in virtual machines, containers, or Service Fabric as well. We really have done a lot of work to make Linux a first-class citizen. So let's talk about some of the application innovation that gets enabled and lit up by Windows Server 2016. So the first is you're able to take existing applications, and if you take those applications and run them as is on Windows Server 2016, they get a lot better. Next is you can take those applications and you can evolve them using new technologies, or you can go and create brand new cloud, born in the cloud applications. So existing applications, you can take those and you can run those in existing VMs. When you do so, they're far more secure than they've been in the past. We'll talk a little bit about that in the future, but they're far more secure. We consume fewer resources than we have in the past, especially if you're using Nano Server, dramatically fewer resources. So things start up quicker, more memory available to you. Additionally, I don't know if you've seen this, I don't think I have it in my deck further on, but Windows Server 2016, if you have an application that likes lots of resources, we can give you lots of resources. I don't know if you've seen this, but Windows Server 2016 supports, you ready for this, 24 terabytes of RAM. 24 terabytes of RAM. Is that crazy or what? And so at some point somebody's like, well, what are you doing? Just gilding the lily? Just stomping on the grave of your competitors? And they say, no. Turns out that there's certain platforms or applications that really take advantage of that. So if you're familiar with Hackathon or the in-memory SQL, they love lots of memory. Or SAP, it loves lots of memory. The VMs in the Windows Server 2016, you can have 12 terabytes of VM for them. So just a great environment. And as I mentioned, you can take those applications and you can put them and containerize them. But then you can also build these new cloud-native applications, right? So what I'm saying is Windows Server 2016 is a great application platform for existing stuff you're modernizing, and brand new stuff. So let's talk about running existing applications with more security. If you're not up on events, man, security is really popping. Honestly, we've been doing this for quite some time. Started with Bill's Trustworthy Computing Memo, and year after year we have invested vigorously in security. And year after year, we have hoped and believed that, hey, when we do this investment in security, people will adopt the latest version of the operating system. They will prefer our version of the operating system over the competitors, etc., because of security features. Year after year after year, just being quite honest with you, we've been proven to be false. that those hypotheses have been proven to be false, that we were wrong. The reality is, as much as we invested, people would say, yeah, that's fine, I'm happy where I am. This year, that is not the case. Everyone was shocked when we went to Ignite this year, and the number of people, there was just an insatiable demand to talk about security and the details of security, which is really great because we had anticipated that. Once again, we said, hey, we think things have fundamentally changed. As we did our planning, I kind of observed, hey, I think things have fundamentally changed, and it's time for us to recommit ourselves to security and to invest even higher. I will tell you that the Snowden stuff was a big contributor. We had already been on this path to do Trustworthy Computing version 2, but the reality is when our security researchers would come to us and say, oh, here's a potential threat, often, I would joke and I'd say, well, I think that threat could be solved with another layer of tin foil for your hat. That seems pretty exotic to me. But what the Snowden documents proved was that a lot of things that we, non-security professionals considered pretty esoteric and science fiction were not science fiction at all. They were actually being deployed and used and hurting our customers. And now we just know more about it. So anyway, we had been committed to Trustworthy Computing version 2, but it really was one of those, hey, everybody's in, here's the level of investment. After Snowden, it was, yeah, we're in, here's the level of investment. Windows Server 2016 has a dramatically increased investment in security. And I will tell you that's not just Server 16, but all the Microsoft products. Anyway, so why has this become such a top priority, right? So there's increasing number of incidents. We see it more and more. The motivations have changed, right? 15 years ago, it was kids having fun, drawing nasty pictures on your websites, ha ha ha. To now we see nation states attacking people, for commercial gain, literally putting companies out of business as they steal their IP and give it to local companies. And we're seeing cyber criminals get involved. And the risks have gotten bigger. And so here's just a wide list of things, titles. So if you're not up on current events,
Hey, maybe you haven't been keeping up on current events, but we just got our asses kicked, pal.
so that's kind of the state of cybersecurity these days. Okay. So, and the thing is that this is now, again, moved beyond the level of like individual IT, individual developers, the security team. Security has really become a CEO issue. And that's why I think we saw so much of it at Ignite. The CEOs and the boards are now demanding answers. They're demanding plans, okay? So some statistics here, some people estimate about $3 trillion in lost productivity and growth. The average cost of a breach, people estimate to be about $4 million and growing. And a lot of recommendations are for companies to cover about $500 million in liability insurance for these sort of incidents. But I'll tell you, this is all great stuff, numbers, numbers, numbers. The reality is this. In the past, if there was a serious cyber breach of a company, the CEO would fire somebody. Fire the director of security, fire the CIO, fire the CSO. But with Target, it was different. Target, the board fired the CEO, and that was a game changer. That was the game changer. Now everybody's paying attention. Windows Server 2016, boy, did we make some investments, some game-changing investments. Shielded VMs. If you haven't walked through it, it turned out that VMs actually dramatically decreased our security posture. Really, true. So imagine the case you had, here's my server, and I've got Active Directory on that server, right? Okay, well, who can get at that information? And the answer is, well, I don't know, I locked it down, so, pretty much the guy who can get onto that server or who has physical server access to it. But what if somebody came in and stole the server, got access to the hard disk, and was able to look at that and use one of these massive password crackers, right? If they're able to do that, within a couple weeks, they'll have the passwords to all the accounts on your system. But here's the deal. If somebody runs into your data center and rips out your server, two things. One, you got to get in there. Three things. One, you got to get in there. Two, they're kind of heavy, kind of hard to carry out. And three, at some point you'd walk into the data center and you'd say, huh, look at that hole. What used to be there? Right? You'd notice, okay? But now we take that same Active Directory server and we virtualize it. And we run it on Hyper-V. Now who has access to it? And the answer is sort of everybody. Yes, the AD admin has access to it. The hypervisor admin has access to it. The storage admin has access to it. The network admin has access to it. And guess what? Any of those guys can go in there and take a copy of that VHD, put it on a USB drive in a couple seconds and walk out the door, and it's very light, and you're not going to notice that there's a copy missing. And they're going to take that and they're going to crack it, and in a couple weeks they're going to have all your passwords. So what we did was, virtualization, awesome, but it reduced our security posture. Shielded VM solves that by ensuring that by basically encrypting the VHDs in a very safe and secure way. It's actually kind of complicated. We've got some great sessions out there, but it is a game changer in security. We have hypervisor. We can now run that on Nano Server, and we have virtualization-based security. Virtualization-based security basically says that we have a special environment that's protected by, basically, you should think of this as in the operating system, you have ring 1, and then the kernel is ring 0. Effectively, what we built is ring -1. Okay, ring -1. It's basically a set of services that says, I don't even trust the kernel. Okay, and in ring -1, we're looking to make sure that the kernel's always kept, has integrity, and we store the secrets in ring -1, not in ring 0 anymore. So if somebody cracks the machine, cracks the kernel, they still don't get the secrets. Okay, we have secure containers. We'll talk a little bit about that more. We spend a lot of time on privileged identity, managing privileged identity. Here's the thing you should understand. Identity is the new attack surface, right? A lot of people think, oh, it's all about 0 days and all this esoteric stuff. It is not. It's about, I'm going to send you a piece of email. It's laser targeted. By the way, don't fall for the trap that thinks, oh, if somebody clicks on a phishing mail, they're a bunch of idiots, and we just need to educate people. No, my friends, that's not the way they do this. They're ultra sophisticated, right? Anybody got a LinkedIn profile? Yeah, everybody's got a LinkedIn profile. They go to your LinkedIn profile, they go to the social media, they see what projects you're on, they use the projects to find other people on the projects, they see who you work with, and then they send you a mail that looks like they're sending it from their private Gmail account versus their work account. Hey, Bob, this is Joe. I was talking to Mary about the Foo project, and we have a time-critical thing. You got to take a look at this document and tell me if it's accurate. The boss, 3 levels up, Tommy, wants that ASAP. I mean, these are laser targeted. You are not an idiot for clicking on these things. You click on it, they get the password. From getting that account, it takes less than a day to get admin privileges or domain admin privileges. Once you have domain admin privileges, they're there for typically over 200 days before you can find them. Okay, so they're pretty sophisticated stuff. So we got a number of things in this release to protect against identities. Credential guard, just-in-time administration, just enough administration. Lots of hardening the platform stuff with threat stuff, but then we're taking a more modern approach to security. This is something we call assume breach. In the past, the vast majority of our efforts have been focused in on avoiding a breach, keeping the bad guys out. We continue to invest in that, but now we're also investing heavily in saying, look, the guy's in here. How am I going to detect him? How am I going to thwart him? How am I going to disrupt his attack? How am I going to get out? How do I re-protect my systems once I got them out? Okay, so containers provide this nice DevOps. By the way, how many people here are devs and versus ops? Devs. Oh, great. Ops? Okay, mix, but largely devs. Okay, so how many people here are on the path to implementing DevOps? Okay, there should be more, okay? Here's the thing, when you talk to, I go to a lot of DevOps conferences, okay? And what is DevOps is often a very heated argument, lots of discussions. Nobody ever walks away from those conversations saying, oh, now I get it. I will tell you this, for me, the heart of DevOps is one very simple concept, and it is this. Together, as a company, we are going to put the customer in the center of everything we do. And we're going to re-engineer our practices, our policies, our processes to drive maximal customer value. It's that simple. Now, it turns out that when you do that, a set of things flow naturally. And that is, we want to be able to listen to our customers, and we want to be able to respond, and we want to be able to respond quickly, and then we want to get it out there and listen, did we get it right? And if not, let's do it again, quick, quick, quick. So small batches. In order for small batches work, you really need to have a great partnership between the developers and operators. Now, a lot of people will talk to you about this as, it's happiness, it's the right thing to do, blah, blah, blah. Those are all true. But the heart of it is, if you do these things, you become an organization which can move faster and deliver more things to your customer. And that is a self-reinforcing cycle. Guess what? The people who do that are delivering more business value. So I go to a lot of these DevOps conferences. 3 years ago, get these people up there and they say, oh, well, here's the innovation I did with my team, and here's what we did, and here's the success we had. It's great. Come back a year later, guess what? They're saying the same thing. Oh, okay, so why are you saying it again? Oh, why you're saying it again is, we're doing the same thing, but now this person is the director, and they're doing it for a much larger scope because they provided leadership, had a business impact, and they were given much larger scope. Okay, so it's that simple. It's not more complicated than that. So next year when I ask you that question, how many of you doing DevOps? I hope to see more hands. Anyway, so DevOps is hard. There's lots of hard things. There's no simple thing. There's no easy answer. Okay, there's not a product you buy. One of the things that helps is this idea of containerization. Okay, I will say that there are two ways to do DevOps. There's the traditional way. The traditional way is doing what you're doing today, but doing it slightly differently. Small batches, better handoffs, things like that. Containers basically is going to do the same things, but it's going to do it differently, okay? Configuration management. It's crucial to have configuration management. It's crucial that that configuration management be repeatable, okay? So one of the things in DevOps is you want to have infrastructure as code. With containers, exactly the same thing. The difference is that with traditional DevOps, that's being done by the operators against instances. With containers, it's being done by the developers in the build lab, and they hand it off. So it's the same set of steps, but one allocation in one model, another allocation in another. So here's how that looks. So with containers, the developer goes and he builds things, they configure things, they test them in their environment, and then they sort of take a snapshot of that environment, and they hand it, and they go and they put it in a central repository. Version control, central to DevOps, okay? Then the operators take that and they'll deploy that, they'll monitor things, and they'll work with the operations and the developers get together to take a look at that monitoring and decide what actions need to happen. In this case, the change, because you're using containers, the change is most often done by the developer, who the developer will take the code, produce a new value, new instance, a new container, test it again, and then flow it, okay? And one of the reasons why people like containers is you're able to do this pretty quickly, okay? Now, let's talk about containers. How many people are using containers today? Oh, okay. Okay. So containers, here's your traditional stack. Hardware, operating system, application. Virtualization basically virtualizes the hardware. You get an x86, you get an x86, you get an x86. Happy days, right? Problem is, then everything gets replicated after that. Containers basically says, I'm going to, instead of virtualizing the hardware, I'm going to virtualize the kernel. So now, you get a kernel, you get a kernel, you get a kernel, but it's all really the same kernel. And what that means is it's much lighter weight, okay? Now, we have two types, Microsoft has two types of containers. The other guys, they got one. The one that they have is, our version of that is called Windows Server Containers. Windows Server Containers. These provide maximal speed and agility. And then we have something called Hyper-V containers. These provide great isolation and performance, okay? Now the difference here is the level of isolation, right? With the Hyper-V containers, you have true hypervisor protection, right? And the other ones, you don't, okay? So in the traditional Linux-style containers or the Windows Server style containers, you are not gonna host on the same machine Hillary Clinton's mail server and the KGB's workload. Like, don't do that. That'd be a bad choice. But with Hyper-V containers, probably still a bad choice, but you could do that, right? You get virtualization protection. And it's really quite great. So by the way, here's another way to think of this, right? Is everybody familiar with the job object? Okay, the job object. Windows Server containers, think of, like, we finally got the job object right. That's one thought, right? A job object is an operating system construct that allows you to associate multiple processes and treat them as a single thing, okay? Single thing for like resource management. So finally the job object's good for resource management, okay? Here's a collection of processes. This collection of processes have this amount of I/O, this amount of CPU, this set of processes, this amount of I/O, this amount of CPU, right? So now all of a sudden you have your own swim lanes. As an extra thing that we do effectively, here's the way you want to think about it, is we took the job control block and we put an extra field in there. And that field, everywhere in the kernel that you have a namespace, something like a file system or the list of kernel locks or the registry, basically we go and we say, hey, I'm going to go to the job. Is this part of a job? And if so, I'm going to get my tables for that here. So each one of the job objects has their own set of tables for namespaces. Okay, so you have different namespaces. That's why with these virtual Windows Server containers, when you look in Task Manager, every single process in every single container you see, they're all that way. With the other environment, Hyper-V containers, it's a true hypervisor process. You have one process, right? In that process, there might be a gazillion, but to the host, you only see one. Okay, so that's what's going on there. Visual Studio Code. Visual Studio Code is now our cross-platform editor. It's free and it is awesome. Has great support. In it, we have Docker support, right? Support for Docker files, support for Docker Compose. Just great support. Additionally, Visual Studio 2015 has great Docker support as well. In Azure, we now have Azure Container Service. The Azure Container Service, we're supporting all the Docker tooling, APIs, all that good stuff. We can support all the various orchestrators, but we have a container server of our own. It can support Linux or Windows containers, and this is currently available in Azure, and I will also be making that available in Azure Stack. So now let's talk about new applications, okay? So these are what we like to call born in the cloud applications, right? These are built and architected and designed with the cloud in mind, okay? And with that, it's all about this constant innovation, listening to the customer, finding out what they need, iterating, doing it quickly, doing it in a way that I'm not screwing you up and you're not screwing me up. And if we're successful, we can scale without any drama, okay? One of the key fabric components we have here is Service Fabric. Now let me be clear. There are lots of things going on in this space, right? These are container orchestration services. Service Fabric is a container orchestration service as well, but you don't have to run things in a container for Service Fabric. It's a very rich environment that supports building cloud applications. Honestly, this is what we're building most of our cloud services on. I think we are not doing as good a job as we could in documenting how we're building our stuff. We've talked about that. We're going to try and get that fixed. We should have engineering blogs that say, hey, see this great service here? Here's how I built it. here's how I'm using Service Fabric, and actually where we'd like to go is to open source some of that stuff so you can actually see the code. That's a dream, not a plan, but I just wanted to make you aware of that. The thing I wanted to point out here is that this Service Fabric is an amazing technology, and it's the technology that we are using to build our cloud services. So I encourage you to take a look at it and consider making it the basis for your cloud services. The great thing about this is really that it just takes care of a lot of the messy stuff. So as developers, you get to focus in on what really matters, which is features for the customer and not a whole bunch of like minutia, right? And what that means is it's going to tell you how to handle things, what interfaces to implement, but having implemented those interfaces, it provides you tremendous value. Okay? It automates the scalability, it automates the reliability, it has a Paxos cluster model, so it does leader election. It has a health service, so it can find out what the health of things are. It can monitor when you need to scale up and when, after having scaled up, demand is decreased and auto scales down. It does all that stuff for you, so it's well worth taking a look at. Windows Server 2016, this is where I spent a lot of my time, Nano Server. We have a new installation option called Nano Server. We have 3 installation options in this version. There is server with a desktop, okay? A server with a desktop, it is focused in on small business scenarios and remote desktop scenarios. Those are really the only scenarios you should be using a desktop with a server. Then we have Server Core. Server Core is the server core you're familiar with, okay? And it's for using existing heritage data center applications, provides great compatibility for that. But we really see all new applications being written to Nano Server, right? Nano Server runs in containers, it's great for modern applications, and there are really 2 scenarios I'm going after it to begin with. Ultimately, it will be the basis for all server scenarios. In 2016, Nano Server has 2 scenarios. First is cloud infrastructure. So we have the hypervisor and our storage stack and failover clustering work great on Nano Server. The second is these born in the cloud applications. So we've got .NET, we've got a bunch of the other language frameworks, Node.js, Ruby, Python, all those run great in this environment. Now just to get this in focus, server with a GUI is about a 10 gigabyte VHD, 10 gigabytes. Server core, about 5 gigabytes. Nano server, 480 megabytes. Windows Server, 480 megabytes. A Gen 2 VM on SSDs, Windows Server will reboot in like 2.5 seconds. Anybody ever seen Windows Server reboot in 2.5 seconds? You see it. I think I demoed it for people, and they're like, "Wait, no, what happened there? I'm sorry, could you do it? What?" I just didn't catch that. Let me do it again. Let me do it again. Let me do it again. It's just amazing, and it will delight you. Anyway, so this is really something else. So I encourage you to do work with Nano Server. Now, it is a version 1, okay? So we want your help, and if we've missed something, let us know. There is an SDK in Visual Studio. So in Visual Studio, you can now say, I'd like to build a Nano Server project. It will show you, give you support in IntelliSense, showing you the APIs that are there. If you import some code that doesn't have an API supported by Nano Server, it will give you the red squiggle mark saying, yeah, you're gonna have a problem there. Nano Server has no local logon. No local logon. No, look, people are like, oh, no, look, that's the right thing, right? When you have a cloud application, it's a different thing than a server for the masses. It's different than an enterprise server, and it's different than a data center server. It's a cloud server. You do not want to be managing it, local logon and like tweaking things. If there's a problem, right, this is that pets versus cattle, right? Pets, pet gets sick, you put all your effort, you get concerned, there's drama, you try and nurture it back to health. With cattle, they get sick, you like put them out of their misery and put them on a barbecue grill, right? There's just no drama. You get another one. There are no cows named Fluffy, right? It's like 1, 2, 3, 4. Sorry, no emotional attachment. That's the way you want to be with your servers, right? Something goes wrong, get rid of that thing, get a new one. Something goes wrong, go back, change something, get rid of it, replace it with a new one. That's the model. So local logon, the fact that there's no local logon is not a problem, it is a benefit. It's going to force you to do the right set of things. Now you can remotely manage things. All your remote GUI stuff works with Nano Server. In fact, many of them get much better. We have a new tool called Server Management Tools. It runs in Azure, and you can use it. It's an Azure extension portal, and you can connect to your Nano Server machines and manage them through a web GUI. Really quite amazing. We have a Nano Server builder image builder, excuse me. Typically, this is done through PowerShell. Got a number of requests for a GUI, so we layered a GUI on top of that PowerShell. You have two paths here. One is to create the Nano Server image itself. The next is to take that and create a bootable USB media from it. You then go and you'll say, here are the things that I want, and it will generate a VHD. You can boot from that VHD or create a VM from that VHD. In order to manage in order to manage Nano Server does not have the full .NET framework. Nano Server has the .NET Core framework, okay? PowerShell is core to all of our management. PowerShell is a .NET framework-based management system, and so we had to refactor it to run on Nano. And this is where we'll be putting all of our effort going forward, is in the Nano Server-based, or the .NET Core-based version. So it is based upon PowerShell version 5, ton of work done on desired state configuration, on security, galleries for sharing, classes. PowerShell support now supports classes, like literally classes. You can subclass .NET classes. You can implement .NET interfaces. And the result is, guess what? A .NET class. That's right, you can have a .NET class implemented in PowerShell. We have support in Visual Studio Code, Pester for unit testing. It's been, as I say, refactored to run on .NET. Has full language compatibility, but the individual commandlets come from different teams, and those different teams need to make sure that their commandlets work on .NET Core. Some do, many do not at this point. That will be coming over time. We have added OpenSSH support. Okay, now this means two things. First, OpenSSH client and server will be available on Windows client and server, and that we're taking OpenSSH and we're bringing it right into the heart of PowerShell. PowerShell remoting will now have a choice of protocols. You can do PowerShell remoting over WinRM, over PowerShell Direct, that's the VM bus, or OpenSSH. We have open sourced PowerShell on GitHub and made it available with an MIT license. If you're not familiar with the MIT license, it's incredibly permissive. You can literally go grab that code, change it any way you want, and sell it. Literally, you have the rights to sell it. Okay? It's incredibly permissive license. Alpha versions of this are now available on Mac OS and Linux. So where we're going with PowerShell is it is going to be the infrastructure, the management infrastructure to manage your hybrid cloud. You'll be able to manage using any client you want, to manage any server that you want, running in any cloud that you want, or on premises using any hypervisor you want, any storage subsystem you want, or any networking subsystem you want. Okay? It's going to be the one-stop shop. Nano Server has been optimized for containers. You can run containers using Server Core or Nano Server. Either one's fine, but Nano Server is dramatically smaller. And what I did with Windows Server 2016 was I knew that to be successful in the cloud, we're going to really have to define this interface, make it great for DevOps. Here's a gotcha. Reality is we've always been sort of silent on the handoff between developers and operators. We just sort of let 1,000 blossoms bloom, do whatever way you want. And in reality, that's not very good. That also caused 1,000 conflicts to bloom. So what we did in 2016 is to define that interface between things. So as developers, now there's a new set of things we're going to want you to do. So first is we have a new installer. This is the Windows Server app installer. We have a new way to do packaging and repository management. That's the PowerShell package management subsystem. We have a configuration management with desired state configuration, operational validation testing, and secure operations. Now, a number of these are available down level as well. They go down level to 2008 R2. So first, word about MSI. MSI was so close to being useful, but these custom actions really were just the portal to hell, right? And it's like if you got a nice 55-gallon drum of wine, like the finest wine you can go, and it's, oh, that's beautiful. And then you take a cup of sewage and you pour it in. You know what you get? 55 gallons of sewage. And that's what these custom actions were, because they totally destroyed what was an otherwise very useful model of a purely declarative system. WSA is that new declarative system. There are no custom actions in it. Because it's purely declarative, it allows me to do two things. One is I can do offline installation, I can do offline servicing, and I know with metaphysical certitude what changes were made to the system when that thing was applied, and how to take it off and undo those changes, okay? So that's what you need to run in the cloud, seriously. So, sorry, I know that's a pain in the butt to a lot of people. MSI just wasn't gonna get it done. Package management, here's the model. There's lots of different repositories in our world, right? The NuGet guys have some stuff, which is different than the Node.js guys, which is different than the PowerShell guys, which is different than this. And what do you care, right? You just want to say, find me my stuff, let me use it. That's what PowerShell package management does. PowerShell package management is an architecture to deliver you a coherent experience of finding, installing, and managing software independent of where it came. I'll work with the developers to make sure that they deliver to you in a consistent way. So what you're going to get with this is you're going to say find a package, and you'll be able to find it wherever it is. You'll be able to save that package, download it from a repository, put it in a system, take a look at it. You'll be able to install it. You'll be able to get an inventory or uninstall it, right? Simple set of things applied to any environment. So you want to make sure that your stuff works with the package management system you want to use with PowerShell package management. Desired state configuration, again, purely declarative way to say what the state of the system should be, hand that to the system, and have a goal-seeking engine make sure that it gets in that state, stays in that state, or reports to you if it deviates from that state. Desired state configuration is a platform, and we work with the various DevOps tools to make them great, okay? So if you're considering a DevOps tool, configuration management tool, you should ask them one question, that is, do you support desired state configuration? And if they say yes, then what that tells you is they will be able to manage all the resources on the Windows box consistently, the same as anybody else. If they say no, run away, okay? Because you're going to end up on the island of misfit toys, okay? Then if they say yes, then you can go and talk to them about their features and how their features differ from somebody else. But if they're not supporting the platform, that's not a path to happiness. And the good news is everybody's pretty much getting on that page. Desired state configuration goes down level and is available on Linux. So this technology is going to be a way you manage everything in your cloud environment. We believe that you can configure things perfectly, but they are inoperable. This is why you need not just unit tests, but you need operational validation testing. Operational validation testing, think of it this way. You might have a server which is perfectly configured, and you go and you check, everything looks perfect, but somebody forgot to plug in the Ethernet, right? So it's not operational. So what we've done is we've taken Pester. Pester is a unit test framework for PowerShell code, and we've modified it with a very thin layer on top to make it great for operational validation testing. So you see this looks like any unit test framework. You describe the scenario, you set some parameters, you describe a test, you run a test, and then you assert values. And what that then allows you to do is to run this, and you see this world here, right? The SQL server should be running, the SQL agent should be running, should be listening to this port, should be able to query information from the SQL server, and all that's happy. Now here's the way I want you to think about this. It's Patch Tuesday. You just patched all the servers in your system. When do you get to go home? When do you get to go home? Who knows, right? You just don't know. The real answer is most people just hang out by the phone for a while. They pray that nothing goes wrong, and if nobody calls, then yeah, it's probably fine, go home. Well, that's kind of a crummy world. That's not the world we want to be giving people. So first, what you want to do is you want to have operational validation tests for all the important components of your system. You want to run those tests before you patch. Before you patch. Because if things aren't working before you patch, I'm not sure you want to go changing them first. Okay? Then you apply the patch. Then you run the tests again. And if they're all working, it gives you an indication that you're in pretty good shape. Now, if it turns out you go home and you get the call, hey, you broke something, well, you go in and you address it, and the very next thing you do, update your operational validation test to check for that thing. So then look, it's just the same thing you guys do with your code. But now we want to help, you need to help the operators do it with the operations so that we can have a world of no drama operations. That's what we're doing there. Now, Windows Server 2016, lots of questions around licensing. There are two licensing models. There's the LTSB licensing model. This is the thing you're familiar with, right? It's the 5+5 servicing, security and quality fixes only after that, no new functionality after that. And this licensing is available for server and with a desktop and for server core, but not for Nano Server, okay? Nano Server is a cloud technology. It has a different servicing model. It has the current branch for business model. Nano Server will only be CBB for now. What changes is that it's a fixed forward model. Okay, as things happen, you get new features, new bug fix, etc., but they will come in new versions, right? The servicing of it will be for a limited time only, and then you'll need to go to the new version. So as I mentioned to you, this is the application platform we recommend you adopt. Azure and Azure Stack so that you can run anywhere. Your code can run anywhere. You develop a set of skills that when you decide you want to go to another company, you have maximal addressable market for your skills, whether that company is doing stuff in the public cloud or they're selling stuff to companies, you'll be able to work for them. Build that on top of the Azure Resource Manager, use containers, virtual machines, Service Fabric, great platform. Now I want to stop here and highlight this idea of there are these different eras. And the different eras, things were done differently. I mentioned to you the different management models, but the types of applications and the way you write the applications differ as well. And what's important is to understand what you're going for, okay? And if you decide that you want to be in the cloud era, it's absolutely critical that everything lines up. Because the one sure way you have to fail is to want to go somewhere and not have the employees, the management support, the tools, the designs, the partners that are going to go there. So if you don't have that, if they're not committed to going to the cloud, you need to get new ones or you won't get to the cloud. Now, I strongly encourage you to get to the cloud. And I will tell you this, the cloud is perhaps the biggest technology transformation I've seen in my career, and I think it'll be a while before we see another one of this order of magnitude. And here's the thing to get in focus. I want you to step back and think about the people running your company today, okay? Your CEO, your CIO, all your C guys, all your vice presidents, all your directors. And I want you to realize something. Within 10 years, and probably within 5, and maybe within 3 years, those people are going to be gone. And they're going to be replaced by people who have been able to figure out how to take the power of the cloud and use it to transform your business. And the question is, now think about the people you work with and realize that those are potentially the candidates for running those jobs, taking those positions. But you know what? There's a difference between them and you. And the difference is you're here. So you are actually in a better position to be the people taking over those new positions because you're investing in yourself. And I really want you to embrace that and ask yourself, why not me? Why don't I lead my company to take advantage of the cloud? And if I can't, why don't I leave this company and go do it for a company that I can do it? Because I'll tell you this, right? So I introduced myself, I'm a technical fellow. Let me help you put that in focus. Microsoft has over 100,000 employees. Technical fellow is the highest level individual contributor. There are only 8 individual technical contributors that are technical fellows in a population of over 100,000. Now, I don't know about you, in our industry, there's this thing called the imposter complex. I have the imposter complex terribly, right? Every day that I go to the office and I put my badge next to the door and it shows a green light, I'm shocked and amazed and delighted, right? Because how did I end up here? And the answer is this. When Microsoft was in the enterprise era, I looked out and I said, this is not right. You know, where we need to be is the data center era. We need to be doing things dramatically different. I know you think you're all successful because of that GUI, but I'm telling you, if you stay with that, you're going to die. That is not how you scale things. That's not how you automate things. We got to go do this. And I encountered a lot of grief, a lot of grief. In fact, I took a demotion to go work on PowerShell. It was the most painful period of my career. But I was right, and the transformation came. And it came, and all of a sudden, there was I, the guy. Now all of a sudden, the company's hair's on fire, and I'm the guy that looks like a bucket of water. So I did very well through that. And I went through that and came out a distinguished engineer and then a technical fellow. So how did that happen? And the answer was, I saw that change coming, and it took conviction. It was not easy. Nathan Myhrvold has a great phrase. He says, if you see a parade, and you run in the front of it and start walking, you're not leading. Leading means bringing people where they wouldn't otherwise go if not for your actions. So I encourage you, the people who lead their companies to adopt this cloud transformation and transform their business because of it will become the new leaders, and it can be you. So I encourage you to do that. Have the courage to put it out there, and it's worth it. It's hard. It is hard, but I encourage you to do it. Anyway, that's the end of my talk. Thank you very much.